So here it's about verifying like whether two things are making a true statement. And so I think in the notes, can we see your notes one more time?
Yep.
Let me just see this and then tutorial expression is yeah, so I like how your second side is to determine whether it is an identity. So it's all about, it's about like being able to algebraically prove that the left side is equivalent to the right side.
I think, yeah, I can see why IM wants us to do this as well. With proving identities, I think I need to, well, in the future when they do trig, they will need to do some sort of like proving that, proving trig identities. I think that's what they're trying to get at.
So I think maybe one of the questions is, or maybe a question that a student would be thinking would be like, what is the reason that they would want to know identities? Like, what's the usefulness of this?
I can give them two reasons. One, knowing a polynomial identity can help you multiply two binomials together without using the box method, or multiplying two polynomials without using the box method. Secondly, what we're doing right now is kind of like a short introduction to some very high-level mathematics that involves proof writing. And so verifying whether something is true is part of writing a proof. And so maybe that second reason would be someone that I tell to like Jonah or like Charles.
Your
or
students
like
who you're really pushing towards AP calculus.
Yeah. Like the folks that are like, I'm ready for AP calculus.
So that's, I think those are two really great things to address. Like one, this is like you know, in 9th and 10th grade, you were doing a lot of like algebraic manipulation that was aimed at getting a solution to a problem. But now as you're moving towards calculus, we're working towards some higher level math skills, like how do we prove things are mathematically true? And this is kind of one of their first sort of tastes of that type of math. So drawing their attention to the fact that this is in some ways a different type of problem than they've been asked in the past. And then also that sort of, the second thing I heard you saying was more about like kind of algebraic fluency, like being able to understand different forms of expressions really like fluently, and like being able to recognize that this is the same as that could save you time, then you don't have to multiply it out every time.
Right, and like I think with this lesson alone, I think it would be good for the folks that are like pushing towards that AP calculus like path. What I'm wondering though is like this, like today, like my lesson on end behaviors where we did the table did not go as well as I expected to. What happened was that I felt like there was like a lot of divide between students who are already understanding it, they're just benefiting from it, versus like kids who has IEPs and powers. And so like I'm afraid that this lesson will make that boundaries even.
Okay, so then let's
That's
think
my biggest
about,
concern.
let's think about scaffolds here.
Yeah.
This one, it seems like you do already have scaffolds. We've talked about like the box method itself as a scaffold. Being able to like, they don't have to get to this level of it to be able to recognize the pattern. You're gonna do a turn and talk where they get to talk to their partner about the pattern. You already have a lot of natural scaffolding built in. So I would imagine this is gonna be accessible.
What I'm worried about is getting students started on this. Like I'm thinking Gabe, who hasn't really thought about box method for a while now. Like I'm thinking about having an example problem alongside that I can pass along with them and tell them like, hey, could you try it with the example problems on the side?
Yep,
Okay.
I think that makes sense for this, and that's only you're thinking about like helping your highest need students right now, but most of your students are going to be able to use the box method for this. I think this is the one where I'm wondering, okay, and then for activity 2, sorry, I just want to make sure I understand this.
Yep.
Are you assigning them to Sorry,
two.
this is on the whiteboard.
This is gonna be on the white. Should this be on actually?
Is this the one where on the whiteboard you're gonna give them like these?
Yep, I'm gonna give them one of these 8, 7 right here. I'm gonna cherry pick and pick the ones that are the most accessible.
I would imagine number 1 might not actually be work.
Nah, I'm probably gonna throw that out. And number 7, probably.
Yeah, okay, so you're gonna put different ones on the different boards.
Yep.
Okay.
I'm gonna choose
I actually
2,
think this is
3,
pretty
4, and 5. Maybe 6 and 7 would be like I'll stretch like Ciela or like Ella, both Ellas. Maybe that would be the stretch problem for them.
Yeah, I'm trying to think of some. I'm trying to think of a scaffold here. Here's a scaffold I'm thinking of. Because what I'm thinking that your students who are not quite ready to look at alphabet soup might be needing is something with numbers first. Here's one that is more 10th grade level, but that could get them into this. Is let's say on their board they have 2 problems. And the first problem is to verify whether this. So that's just step 1 is verify this. And then step 2 is number 2 here. So, and I would actually write it this way so that it mirrors, right? Right? And so now what you could do is you could say, marker to the student who needs more support, they write first, they do 1. Pass the marker to the students who are more confident to work on 2. So they're still collaborating, but students who are maybe less likely to engage with this, they could still engage with this using the box method and seeing how you could prove that this does not equal that, right?
And then they would be like, they would be able to use the box method right here
Yeah.
for gaps, and then afterwards realize that it's gonna look
And
exactly
then
like
actually
this.
what happens is that this one, which does end up being a correct identity, kind of proves what was wrong with this one because you're missing this term right here. What do you think about doing that?
That's actually a really
I'm thinking
good
you
idea.
could have like some groups could do this, and then some groups could do the same thing but with the minus. So you could have this for the other groups.
That is something I can try. I think that would be much better than what I have anticipated and have said right now.
Yeah, because I think and this just to name, this is a really common technique for scaffolding in math, which is if you have a problem that's purely algebraic, it's all variables. Try to make a simpler version of the problem, one that involves numbers first, so students can kind of make sense of the structure of it with numbers, and then they do it with variables.
Got it. So let's say in some sort of world where there are variables, okay, does the first problem, and then I don't know, Kai does the second problem. How do I prompt Gabe to connect between these 2 problems? Would I just circle would I just highlight what does this term this problem has?
I would use the box though. I would have them see it in the box method, right? So let's go back to the positive one because it's just easier to model it. So we have x and 3, x and 3, x squared, 3x, 3x, 9. Okay, now I'm gonna write this out and show, okay, so this doesn't work here, okay? And to make this more realistic, let's say, so say Priya does this, right? And then Catherine does this. So A and B, A squared, AB, B squared, A squared plus 2AB plus B squared. And that is the same. Okay, so now you're trying to get Cypriot to understand what Catherine did. Okay, look at the box method. what do these ABs represent in your box method up above? What was in those boxes? 3x and 3x. Okay, what's the relationship between 3x and 6x?
They're the sum.
It's a sum, yeah. How many 3x's were there?
6 in total.
6 in total. How many squares with 3x are there?
2.
2. How many squares with AB are there?
2.
2. So do you see where this 2 comes from with the AB? Okay, so this 2 AB is just the same thing as saying 2 times 3x, and we know 2 times 3 is 6. So now can you make sense of where these are coming from? Does that make sense as like a way of kind of using this as a scaffold for understanding this? So basically every board would have like one of these and one of these on it.
Yep.
And then I think from there, the question would be, I'm wondering if you